Welcome.
So, hola, EuroPython. Thanks for coming to my talk this morning. My name is Carrie-Anne, and I'm going to be talking about education. And this is perhaps not the most exciting keynote that you might have come to this week, but I'm hoping to give you some kind of insight into this current movement around computer science in education. So, my name is Carrie-Anne, and currently I work for the Raspberry Pi Foundation. But if someone was to come up to me and say, if you could describe yourself in one word, what would it be? That word would be educator. Okay? I see myself as an educator. You know, I was a teacher for a long time. And whether I'm teaching in a classroom or teaching through a book or I'm educating through online resources on raspberrypi.org, you know, that is what I do and that's what I'm about. For anyone who doesn't know about Raspberry Pi, I've had some really odd conversations this week. I've had quite a few people, when I'm talking about Raspberry Pi, go, oh, you're a charity? Yes, Raspberry Pi Foundation, we're a charitable organization. When you buy a Raspberry Pi, 100% of the profits from that go into the charitable foundation, so we are able to meet our charitable mission, which is to advance the education of adults and children in the fields of, you know, computers, computer science, and related subjects. And this part, related subjects, is really important to us, so things like science, the arts. There's lots of subjects that we're really passionate about. I guess you could describe them as kind of digital making. You know, we're really keen in that kind of field as well. So because I work for the Raspberry Pi Foundation, I spend a lot of time thinking about how children learn with computer science. And I'm not alone in that. Today with us is Ben Nuttall from the Raspberry Pi Foundation. James Robinson is here as well today. And one of our prolific volunteers, Alex Bradbury, is here from Cambridge University too. So today, at any point, if you want to talk to us about computer science education, or in particular about Raspberry Pi, do approach one of us. They're usually wearing Raspberry Pi t-shirts. I'm not today, but they're pretty easy to spot. So this is kind of where my journey started, in the classroom. I was teaching a subject called ICT. You can tell I'm teaching. Here are some children longingly and lovingly, you know, looking up to me. Yeah, that's standard. You know, that doesn't always happen. This is clearly a posed photograph. And one of the only photographs I can use, right, because you can't see the children's faces. But around this time, I was teaching a subject which was called ICT. And in 2011, Google's Eric Schmidt made a speech in the UK in which he said that, you know, computer science education in the UK was really, really bad. And actually what we were doing was not teaching children how to be creators of technology, but rather consumers. And our press in the UK is not a huge fan of teachers, so they kind of mistook his words, and then there was a big push in the media about how all ICT teachers are terrible, how we had no skills, we certainly couldn't program, and so we were doing a terrible job educating the future, which was really depressing for me at the time. But I continued on, and I started to think about ways in which I could take hold of this new wave of thinking around education into my own class. So I heard about this thing called Raspberry Pi that was coming out. And that was around February 2012. And like millions of other people, I tried to get one on the day they were launched from the website, which crashed quite a few times. And eventually, in about May, my Raspberry Pi arrived. And I plugged it into my TV, and I got it started. And then I kind of thought, well, it's a computer. It's a Linux computer. I've used one before. This is nothing new. Like, what am I supposed to do with this? How is this going to revolutionize my teaching? You know, I've been told this is for children. How can I do something with it? So I found out that there was some kind of user groups getting together, and they were called Raspberry Jams. So these events where lots of people would get together and talk about what it is they do with their Raspberry Pis. So I thought, well, I'll go along to that and see if there are any projects I can take back to my classroom. So I went to one in London, and this was in about June 2012. And it was at Mozilla Space in London. I don't know if you've ever been there, but it's quite a cool space. And there were about 50 men, and there were 3 women, of which I was one of them. And the 3 women were all teachers. And so after a while, a few talks about how people would use their Raspberry Pis to do things like turn it into a games platform, like a Super Nintendo. Someone else had put it in a big track, like an 80s big track rover. So after a few of these presentations, and anyone who's been to Mozilla will know they give you free drinks, so I started to get quite confident. Someone said, why don't you get up and tell people why you're here? Maybe the community can help you. So I got up with the other female teachers who were there, and I said, look, I'm a teacher. I'm really excited about bringing Raspberry Pi into my classroom, but I don't really know what to do. And I've been watching your projects, and I don't mean to be kind of harsh, but they're quite geeky and retro, and I'm not really sure my students would understand that. And then I said something really stupid, which was, and also I don't think they're going to inspire any girls. At which point, someone heckled me and said, well, why don't you get the Raspberry Pi to go shopping for you or organize sleepovers or something like that, which for me was a really kind of awful moment. Anyone who knows me will know I'm quite an introverted person anyway. Even standing up here and giving this presentation is a little bit scary and not typical for me. And so I kind of walked off a stage at that point with my head down. And then something really amazing happened. And about 10 people who were in the audience came up to me and said, please ignore that person who's just said that. Like, we don't agree with anything he's just said to you. How can we help you? And that was really the start of my journey with Raspberry Pi. Because off the back of that, that terrible experience, I was invited to PyCon UK. And that was because that terrible experience was streamed online for the world to see. So not only did I have to walk off stage like this, in a group of 50 people, but also it kind of went a little bit viral because everyone's like, oh, hey, look at this man heckling this woman at a Raspberry Jam. So something good and positive came out of that. I was invited to the Python conference in the UK, and they were having a teacher's track for the first day. Great. So I went along as a delegate, not really sure what to expect. And by the end of day 2, I was running the Education Summit. Kind of just took over, sorry guys. And I gave a lightning talk about what it was I wanted, and really it kind of snowballed. At the time, someone was there, one of the keynotes was from University of Cambridge, which is where Raspberry Pi is kind of born out of. One of the trustees heard about me, and so they sent me someone from Cambridge, and we started a program called Sonic Pi, which I'll talk about later on. And now, I'm on the board of directors for the Python Software Foundation. Like, whoa, how did that happen? Right? I went from teaching in a classroom, and now I'm on the board of the PSF. If I can do it, anyone can do it. So to give you some background about where we are in England, we have this new computer science curriculum. It's called computing. It's a computing curriculum. And this is just to kind of give you the basis of what it's about. As you can see up here, from the age of 5, children need to learn how to code and program. So they need to understand algorithms, sequencing, selection, and repetition. Okay? From the age of 11, they need to use at least 2 programming languages, and one of those needs to be text-based. And this curriculum, it's in existence now. It started September 2014, so we've had 1 full year of it. And I think it's really exciting, but it only applies to England. And this is really important that I say this now, because I'll forget later on, because I'll always refer to it as the UK. It's not. This only applies to England. It doesn't apply to Scotland, Wales, Northern Ireland. It just applies to us, which is sometimes a bit awkward. And government data that's been collected said that 55% of teachers lack a qualification that enables them to be able to teach this. And a recent survey by TES, which is the Times Education Supplement, found that 60% of England's teachers were not confident delivering the new computing curriculum. So that's kind of where we are. And the government, in their wisdom, brought in this new curriculum, and then they only invested £5 million in upskilling of teachers. And that works out, just to kind of break that down, that's about £175 per school. And what that means is that a teacher cannot be released from their teaching duties, even for a day. So, and that's per school. So it's not really helpful that they've brought in this new curriculum without any support for upskilling of teachers. Right? This is a problem. So where else in the world are people, where else are there curriculums? We're not alone in Europe. We're at EuroPython, so we should talk about Europe. Estonia have also moved towards a computing curriculum. Ben Nuttall, the Raspberry Pi Foundation, he's working with teachers in Estonia, and we've had some on our teacher training course at Raspberry Pi, to try and help them with upskilling as well, because we found out that they're in a very similar situation, that they have this 100% sure what to do with it. Australia, very recently, have now got a new curriculum, a new computer science curriculum. If you check out PyCon Australia last year, Dr. James Curran gave a really fantastic talk. That process in Australia and New Zealand as well. And Israel have had computer science as part of their curriculum for quite some time now. So this is it. We're like the pioneers of this around the world. And there is this real movement at the moment to bring digital making and computer science into schools. We've recently been to the States and had quite a lot of conversations with teachers about this. We're all really super excited. Keep talking about coding. And I use this all the time when I say coding. There's this coding curriculum. We need to teach code. It's kind of becoming a bit of a fad term. I'm really keen that doesn't happen. Last year, I went to visit Denmark, and I gave a talk there. And it seems like the Scandinavian countries are very close to perhaps adding this to their curriculum too. So I think we're going to see a kind of snowball effect. And you might be thinking, well, actually, why should we bother teaching computing at all? Like, why do we need to teach computer science to children? Why can't they just learn how I learned with some books and some online tutorials? Well, the first reason is that children just are creative and imaginative, and they're not afraid of failure. And something that's really terrible that we do as educators is we train them out of this. Okay, when students used to come to me, because I was a kind of secondary high school teacher, so I would get them at around the age of 11. And by that point, they had been trained out of kind of clicking buttons and kind of just having a go and seeing what happens. It's really disappointing, because children just are. They will press all the buttons. They will have a go at things, and that's what they will tinker with things. And that's what's really exciting, and that's how we learn. Another reason is to do with social mobility. I think we have a real problem with developers. I think that people who access computer science education and who have jobs in computer science generally have come from a fairly affluent background. I think computer science has the potential to move people socially, move them from really low-paid jobs into really good paid jobs. Another reason is I think computer science is empowering, right? Just being able to write a program and make it do something, even if it's like print hello world, is super empowering. The first time I wrote a computer program, I was like, wow, I've made something happen with this computer. And it made me feel good about myself, and it continues to do that. And I feel more confident as a person to be able to do that. This one, obviously, I'm hugely passionate about, which is about diversity in technology. We've had tons of investigations into this area, and lots of reports suggest that in the UK, 16% of IT specialists are women, and that's in the UK. It's not much better in the United States. It's something around 20%. It's usually around that percentage. And what that means is the people who are creating do not represent the people who are using technology. That's not right. And again, that's to do with social mobility as well. Are we representing the people from everywhere, from every type of background, if they're not, the people creating the technology? And the last one, and I think is the most, is this idea of where we're heading towards just globally. CGP Grey, he makes these really cool videos on YouTube, and he made one called Humans Need Not Apply, in which he talks about how in the future, we're not that far away, most things will become automated. We think about when you go to a supermarket now, generally you might want to use those automated machines where you kind of self-check out. There are baristas where you just make your own cups of coffee just by pressing some buttons. And of course, self-driving cars could actually put a whole bunch of people out of a job. Right? Just think about if self-driving cars tomorrow exist, laws are passed and actually used every day. Bus drivers, delivery drivers, lorry drivers, all these people are going to be out of a job. And I think he quotes something like, it's just a small shift economically, that if there's like 40% unemployment, that actually it could be devastating for the world's economy. And he's quite negative about this. And I think more positively. I think if we train children today for a workforce that will be around fixing those machines or programming those machines or making those machines better, then we're winning, right? Because this is where the jobs are going to be in this sector. But having said all of this, I feel like this argument is kind of over now. I've been making this argument for quite a few years, and I feel like actually I don't need to make this argument anymore. Where the focus is moving away from why we should be teaching it to how we should be teaching it, and that's why I'm here today. And so in the UK, before we had the curriculum, we knew it was coming. A lot of teachers were talking about what programming language should we use to be able to teach this. Okay, so Scratch is an easy win. Everyone's going to use Scratch in the younger years, but as you saw, 11-year-olds need to be able to use 2 programming languages. One needs to be text, so what programming are we going to use? So a lot of people went, well, okay, let's have a look at Python. Python seems like a good option. So why Python? Well, the first reason is that it's used all over the world, right? It's used in real-world scenarios. It's powerful enough for real development. You're all here, you're all developers at a Python conference. I assume you use Python in your jobs, right? So not only is it a good tool for training children, but you can also say, hey, this is used all the time, all over the world. It's used by NASA, it's used by CERN. So this is a good programming language. It has a really simple syntax. And so we use this example all the time. If I wanted to do hello world in C, or I wanted to do hello world in JavaScript, I'm going to have to write quite a few lines of code, like roughly 6, and it's going to have curly braces and parentheses and so on, and that's going to get confusing. When I was at school in the 80s, we had a BBC Micro, and I have really vivid memories of writing print statements in BASIC. And that's what's really nice about Python, is you can write print hello world in 1 line. So it's a great syntax, so we're already winning. And this is the most important one, I think, for educators and for me, is it has this really strong, powerful, helpful community. Community is just so important. I've never felt so welcomed by a community. And the Raspberry Pi Foundation has a really great community, but I would say the Python community probably just about tops it. If I go back to my experience at PyCon UK, the reason why I kind of took over that teacher's track was because, I was made to feel welcome. And when I was there, I met some developers. And after the conference, that didn't end. That kind of collaboration and friendship didn't end. I would continue to, try and improve my Python skills and write code. And sometimes it wouldn't work, and I couldn't figure out why. And I was able just to stick it in Pastebin, send it to one of these guys I'd met, and they would mark it for me. Great, right? Developers are marking my work as a teacher. And that was really helpful for me to improve and get better. And I think not just in terms of national communities or international communities, also local communities. So I've been invited several times to the London Python Dojo. And one time I went along and I stood up and said, why don't we just have a look at the curriculum? Would any of you guys kind of help me try and fix some of these things with Python? Maybe we can come up with some examples and I can share them with other teachers. And I was amazed that they all got really excited about it. They all formed groups, they wrote amazing programs, and then they shared them back with me. And they were so excited about it, they went on to run a whole education special edition of that dojo. So community is what really makes Python special. And I think we should really celebrate that. So I guess we're at a point now where we have lots of education summits as part of conferences. So PyCon UK has been having this teacher track for quite a few years now. When I first went, there was roughly around about 8 to 10 teachers there. And my colleague, James Robinson, is going to give a talk today about his experience as being a teacher going to PyCon UK. That's at 11. So kind of come to this, have your break, go to that. And I think it's really important that we try and welcome teachers into conferences like this. We've seen the PyCon UK education track go from that kind of beginning stages of 8 to 10 teachers to this year. They have tickets for 40 teachers and they're already sold out, well, almost already sold out. And that's coming in September. So if you build it, it will start to come along. Right? So if you organize conferences, I really recommend that you have an education summit. PyCon this year in Montreal had a kind of education track, which was some talks. Here in Bilbao, we're very excited to be helping run the education summit. And straight after this, I'm off to Australia to help with the education track at PyCon Australia. Okay, so I think really what I want to say is if you try by just starting these things. It may be today we don't actually meet any teachers here at the Education Summit. That would be sad. But if teachers see what we're doing, they're more likely to come next year and the year after, and so on. So what I want to talk about is, okay, so Python seems to be like a great language to use to teach, but currently there are some real strong barriers. And I think we as a community can fix those barriers. So I'm going to kind of explain them to you and perhaps show you some solutions, and perhaps we can come up with some ideas. So the first one is transitioning from a visual programming language to a text-based programming language. So what I was doing in my classroom was we were teaching with Scratch with the younger years, and then we were Python. And actually a lot of the children struggled. They really, really found it hard to move from Scratch to Python for a whole bunch of reasons. And this is something we're continually trying to overcome. At Cambridge at the moment, they have some Raspberry Pi interns, and they're working on a project called Pyland. I really recommend you go and have a look at it. And that's like a kind of a game that you play on Raspberry Pi, but you have to use Python to be able to solve a lot of the problems. The next one is everyone's favorite conversation, which is Python 2 versus Python 3. Quite a lot of confused teachers out there that they'll go, oh, my code's not working, my program's not working, what's wrong with it? And I look at it and I go, oh, it's Python 3, and you're trying to run it in Python, in Python 2. It's not going to work. And this is a real problem. But really, it shouldn't be a problem, right? In education, there's no reason why we shouldn't just be teaching Python 3. Really, everybody uses 3 in education. And at the Raspberry Pi Foundation, it's a decision we took early on to ensure that all our resources were written in Python 3. And I would really encourage you, if you are working with children or in schools or helping teachers, Python 3. Python 3 is the answer. Most major libraries are Python 3 compatible now. There's a few that are not, which I'll come back to later. But Python 3 is the answer. I'm just going to keep repeating that. Python 3, Python 3. Please do Python 3. So the next one is a bit complicated to explain, and this is probably where you're all going to start booing me, so please bear with me. So I feel like there's this kind of function that we have at the moment in Python, and this is where sometimes people who write libraries probably aren't aware. Quite often I find that people write libraries for themselves, right, to fix a problem that they've found. But what might happen, surprising, is they may be picked up by schools or by children, and they start using them, they become really important. One of the examples for this is the RPi GPIO library. So a guy in the UK called Ben Crosden, he runs a brewery. And he decided to use a Raspberry Pi to be able to regulate the temperature of his brewery. And so he wrote a Python library to be able to help him do it. It's called rpi.gpio. But the surprising thing is now it's used in all schools who have got Raspberry Pis with children, because it's the Python library to be able to control the GPIO pins on a Raspberry Pi and do some physical computing, which is one of the most exciting things in schools at the moment. And it can be problematic, not specifically that library, but I find with a lot of libraries that are picked up by educators that are written by people who are just using them for themselves, sometimes there are some inconsistencies. Inconsistencies in the naming of functions, and that can be a bit of a problem. One of the most common problems we find with beginner learners, especially with Raspberry Pi, is that quite often they'll create their program and they'll save that file as the same name as the library that they're using. So for example, we have a library called PyCamera, which allows you to use the Raspberry Pi camera with Python, and that library is called PyCamera. And so everyone, of course, when they do their first ever PyCamera program, save it as pycamera.py, and then they wonder why it doesn't work. And this is a really common problem we find, whether it's with an add-on board like Pybrella, same thing with the Pybrella library. It may seem fairly obvious to you, and you may think, oh God, what idiots, right? But you've got to understand, quite often these are children or educators or beginner learners who are just completely new to this, right? I did the exact same thing at PyCon conference in England. I was running a workshop in front of a whole bunch of teachers and a whole bunch of developers, and I accidentally named my file as I was using the Pybrella library. I named it pybrella.py, and then myself and 5 developers stood there looking and going, why isn't it working? Why is it? 5 developers, and not one of them figured it out until a little bit later, because it's not an obvious problem, right? And then there's a lot of inconsistencies with whether you've used camel case or snake case, right? If you're going to use those, like, pick one and stick with it, because it can get a bit confusing whether you need to use capital letters or underscores. And be really aware of that. I mean, I guess we should be using snake case, right? But think about children who are using this. We're talking about 8, 9-year-olds, right, who want to move away from scratch and they want to be learning Python, but they struggle with, just motor skills sometimes and keyboard skills. So you've got to think about, if you're going to use underscores, stick with underscores. If you're going to use capital letters, stick with capital letters, because they need to kind of get used to using the keyboard in that way. And try and make the functions almost guessable names. So if I'm writing something in Python, I can almost guess if I'm trying to figure something out. Well, actually, I want to set this block, perhaps in Minecraft, that I might want to build a bigger kind of set of blocks. Oh, that'll be set blocks, right? That's obvious. I can guess it. And quite often we find with libraries, like, it's not guessable at all, and it's inconsistent. So please try and make them consistent as possible. Yeah, so think more time about naming, because children might use it. So I'm just going to use this example from Minecraft Pi. So anyone who doesn't know about Minecraft Pi, it's an API that you can use to be able to program things to happen in Minecraft. Yay. So obviously educators love this because it's a real hook for children, because they love Minecraft and they can see something instant happening. It kind of blows their mind that instead of spending hours and hours and hours like building a house, like mining what they need to build a house, that you can just do it with a few lines of code. This is the example that we have. A really basic program you would think to get children starting. First of all, they've got to connect to the Minecraft world. Then they need to, use some variables to set some coordinates. And then they need to use this line, mc.player.setPosition. As you can see, there's a capital P, and that's kind of their program. And I find that they fall down on the very first line, right? Just the capital in Minecraft. Like they forget to do it. And children are very impatient. They're used to things happening straight away with tablet devices and so on. Everything's really instant. And sometimes we can lose children very quickly just with things like this. And so I'm just going to show you. So that's the same example. A friend of mine called Sam Aaron, who I'm going to talk about a little bit more later, he's been able to get this work with his system, Sonic Pi, and he spends a lot of time thinking about, because he quite often does a lot of outreach, about how he could improve this with his own system. So please excuse that this is Ruby, but what I want you to look at is the names that he's used here. So you can see the difference here already, right? So MC teleport is just a much nicer kind of sounding word than set pos. Right, set pos, it could mean anything. It means set position, but we're old enough and wise enough to understand that. But children, teleport, it's like, oh, it's going to move my player. So I need to set the X, Y, and Z coordinates. Got it. It's a really nice example. The other one is to do with block types. So with the Python API, you have to use variables. There's this really long bit here, block.glass.id. Sometimes you have to use the block numbers. 108, if you're wondering, it's melon. Yep. TNT is 46. You can test me on those later. And then you need to say mc.setBlock, give the coordinates of where you want to set it, and then, of course, call your variable. And I want glass to be there. That's, again, quite long-winded. There's a lot of capital letters in there as well that children need to deal with. And so how we thought about that with Sonic Pi is, MC setBlock. All the block names are right, so you just have to say glass and then set the coordinates. Again, apologies that this is Ruby, but you kind of get the idea of what I'm trying to say. So basically my point is, if you are creating libraries, be aware that they may be picked up by children. Please be consistent in how you name your functions. This is an example that I'm really excited to share with you all. So at one of the PyCon UK education tracks, I believe it was one last year, there was a lot of discussion between developers and educators, and that's one of the most exciting things about having teachers at conferences like this. So Daniel Pope, you may know, is very good with Pygame. Any of you might know Pygame, the library. It's a really great library, again, to use with children because it's really visual and you can do a whole bunch of stuff. But Pygame I found really difficult to use in the classroom. I think Daniel got talking to some other teachers who said the same thing. And he wrote a very short program for him, which was very short, and a teacher said, I can't teach that in the kind of hour lesson that I have. It's just not going to work. You're going to have to explain event handling. Like, that's not going to happen. I just want them to be able to start thinking about the logic to be able to build a game. And so he went away and he came up with Pygame Zero. I believe he gave a lightning talk about this on Monday. If you catch him around and you haven't seen this, you really need to go and have a look at this. So the idea here is that it just makes Pygame much easier to use. I'd be able to break things into bite-sized lessons. All I need to do is change a couple of lines to meaningful progress, and that's really exciting. And it does make some of the decisions for you. Okay, and we shouldn't be afraid to do that with children, to abstract away a little bit just to get them excited. Sam Aaron always uses this example when he's talking, that with children, sometimes you say to them, okay, so let's do some coding. What do you want to do? And I say, well, I really want to build a game. Okay, let's make a game. Great, this is Pygame library, I can do that, fantastic. What do you want your game to be? Well, I really want it to be set on an alien planet, and I want there to be kind of these crazy monster aliens, and I have a big gun, I want to shoot those aliens, and I want to run around, and there'll probably be a dungeon, because kids are imaginative and creative, and they're going to go on about that, right, for quite some time. And you're like, okay, so in Pygame, I can make you a kind of black screen, we'll say that's like space. I can probably make a circle, we'll call that the planet, that'll be gray, right? And I've already lost them, because in their minds, when they think about computer gaming, they're thinking about Xbox, they're not thinking about 2D graphics. They're just not. So if they're going to do something with Pygame that is 2D, it needs to be something more like Scratch, where they're able to make quite a lot of progress very quickly using their imagination. And with Pygame Zero, I think they're going to be able to do that. So please do go have a look at that and speak to Daniel about it. So another barrier is around installing extra libraries. I see a lot of learners fall down really early on when they don't have the libraries that they need. And it's a real added hassle if I'm going to be teaching a class for the kids. Don't forget, it's very easy to install a library, right, on one computer. You've got 30 computers, 50 computers. It's not so easy. Raspberry Pis, even harder. And so this is something we need to think about. And quite a lot of teachers and a lot of schools, sometimes their devices aren't online because they have to protect the children within the school. And more often than not, they're behind a kind of firewall that stops them to be able to get these things, and a proxy that stops them from being able to install libraries. And so I got talking to Daniel on Monday night, so this is an addition to my talk, where he started to talk about this idea of having an education bundle that you would be able to download, so kind of on top of the standard library. And this could include, commonly used dependencies, and this could include Pygame Zero. So things like NumPy, the Python imaging library, those kinds of things could be in this education bundle. And I wouldn't really mind how that was delivered. If that was built on pip, that'd be fine. All I'm trying to get across here is that we should be thinking for educators. And so the last barrier, and this is the one I want to spend some time talking about, is Python IDE. Finding programming interfaces for children is really difficult. Just out of interest, how many of you use IDLE for your IDE of choice? 2 people? 3 maybe? IDLE is what children have first access to, right? Because it comes included when you download Python. Right? I was very disappointed to hear Guido's talk on Tuesday when he was asked the question, what is your favorite text editor? His answer wasn't IDLE. Right? But this is what children have. And so there are some really good examples of online text editors, some really great examples out there, and I've listed some of them. A lot of you will be aware of Python Anywhere. I think they're doing wonderful stuff with online IDEs. Comes bundled with just so many libraries, which is great. But there are problems around this idea of online IDEs. And I think one of the first ones is to do with the age of children using them. So one of the reasons why I couldn't use the new version of Scratch in my school was because you had to sign up for an online account. And there are issues around privacy. And in England, children under 13, you just can't do that with children under 13, right? So if I want 8, 9, 10-year-olds, 11-year-olds using this kind of online text editor, I can't because they're not allowed to sign up for it. So that's a problem. In my school, I had this huge problem where the infrastructure, the online infrastructure, the internet, super slow, right? It wasn't built and designed for the amount of use it was getting. I couldn't use like Google Docs with my children. Scratch would crash kind of halfway through, so we couldn't really use that. And that was a problem. So if I wanted to use any of these, I just wouldn't be able to reliably use them because my internet was so slow. And again, behind a firewall, proxy settings probably wouldn't allow me to access some of these. They'd most likely be blocked because they'd be seen as an adult, a kind of adult website. Or that, hey, you're going to be like breaking things, so we don't want children breaking things, so we're going to filter that. And not just at school level, but higher up at kind of borough, district level, it would be blocked, and it would just be a nightmare to unblock them. So, and I think there's also a compatibility issue with libraries again. So these are great, and I think we're on the right track with a lot of these. Grot Learning in particular is fantastic, really designed for education and for children. Recommend you have a look at that one. But they're not perfect, and they're not really the solution for everybody. And if we really want to move children socially, and we want to include everybody in computer science, we need to think about children who do not have access to the internet. There are children in this world who do not have access to the internet. Even in England, we have children who don't have access to the internet outside of school. So we need to think about how we can include them. So an obvious example of a kind of offline educational Python IDE would be PyCharm. They have an education edition. It's free and open, fantastic. That's exactly what we want. And they say on their website, PyCharm Educational Edition is not merely a learning system, it's a real development tool. Okay, we're getting back to this. It's a real development tool. Actually, I need to spend some time learning how to use PyCharm because it's not really obvious. Even the education edition is not really obvious for me to get into. And so I think that's a problem. I think this is great for, oh my God, I've only got 10 minutes. So this is probably not great for, this is probably really good for children who are kind of 16 plus. I think this is great. If I was teaching GCSE or A-level, which is kind of between 16 and 20, I'd be using this, right? Because it would be great. 9, 10, 11-year-olds, which is the kind of key demographic we want to be hitting here, this is not going to work. And there's too many opportunities for failure with it. There's too many buttons. There's just too many things I'd have to set up first. I just want to get them on something simple and get them. And also, open source equals awesome source, so it's great that it's open. So we need more things like this that are open, but simpler. So going to my back to my idle problem. So this is what learners have, right? Most people who are new to Python, this is the first thing they come across, which is idle. And it has some really good positive things about it. First of all, it's free. It has syntax highlighting. It does do some auto-indentation, which is good, because indentation is important in Python. It's cross-platform. We're able to include it in Raspbian because it's so small and lightweight. And it's simple, and that's really important here. It's very simple to get started with. However, tons of problems that we find with it all the time when we're using it with learners. Anyone who's used it with teaching children will know there are so many problems. First one, it being in 2 separate windows. No, that needs to change, right? Because that is just a nightmare getting with their motor skills and so on. If they've got Minecraft running as well, it's 3 windows they've got to navigate between. It's not really working too great. The error reporting is atrocious, right? It's really bad. It doesn't really tell you what the problems are in a way that children can understand. So what are the solutions? Well, something I want to show you and I keep talking about is Sonic Pi. So this guy from the University of Cambridge came into my school with a Raspberry Pi, put it in front of me and said, I've got it to make music. Do you think we can teach computer science with this? And I said, yes, let's have a go. It sounds nuts enough that it will probably work. So on a whiteboard, I drew this really simple interface where we had a coding panel and we had kind of was an output. It was kind of showing you what was happening, and then there was an error panel. And since then, that was back at the end of 2012. It's now evolved into this, which you can see here, that includes online inbuilt tutorials, and it's now both a tool for education, so it's a tool developed for education, but it also it also is used by live coders to make music in a professional kind of context, which is very exciting. So I'm going to do the thing that I was told not to do, which is a demo. So just to prove that this is a tool for musicians, this is the kind of music that you can code with it. Apologies, this again is in Ruby. When I told people I was going to show Sonic Pi at a Python conference, they went, really? Sorry. But yes, but what I want to show you is the interface, right? Just imagine for a minute, this is Python. Some really good stuff up here. There's a button right here in front of me. It says run. Right? To run your code in idle, you have to click on run module. Oh, right? And then you have to teach children like control, F5. There's a button that makes it much easier. You can stop it as well. This is really handy, like a keyboard interrupt. This is super helpful. I'm going to blow your mind. Can you people at the back see that code? Can you see all of it? The answer is no. Oh my gosh. I can make it smaller and I can make it bigger. That sounds really like, why are you so excited about that? When you're teaching in a classroom, to be able to do that really quickly, especially when you have 30 children who are all working on their code and they're stuck, to be able to just press a button and make the text smaller and make it bigger, great. We need that in idle. Numbers down the side, line numbers, really simple, really easy. Having windows together, this is obviously using Qt, right? These things exist, that windows together. Let's put the interpreter window with the coding, with the text window. It does have an inbuilt tutorial, which I can get rid of. And other things that are quite exciting. Let me see. Right, so I've written some code here. Obviously, it's Ruby. It doesn't need to be indented to work. We know that's what makes it a great kind of fun starting point for children. However, again, another really cool button is this one here that says align, and it automatically aligns the code, right? And you might be thinking, well, I think children should learn how to indent their code so it works with Python. That's actually really important. Yes, it is, but I think actually we can do this. We can have a function where you're able to turn this on and off, but starting place. Idle does also indent, but really badly. And children will not write, linear, and quite often you'll give children parts of code and you want them to change it up, and their code just gets all over the place. The auto indentation is not sophisticated enough to deal with it. This has these really cool pink lines as well, so I can see where it's indented when we have nested loops and so on. I think that would be really helpful. So that's an example of a really good interface, but obviously that's been designed for education. So we spend a lot of time in schools. So we see where they fall down. Sam spends an awful lot of time testing his software with all demographics. And so that's why he's able to make these changes. But why can't we have a version for Python that's like that, right? I think it's possible. So you're thinking now, how can you help educators, right? You're really pumped up by everything I've just said, and you want to help fix all my problems, thanks. So I've got a whole bunch of ways in which you can do that. The first one is to meet educators, right? If you run conferences and you have education tracks, eventually teachers will come to them, go and meet them, go and talk to them, listen to their problems. So add education tracks to all of your conferences. Run special education sessions at your local user groups, right? And again, teachers will come and you'll be able to talk to them and help them. Mentor a teacher. If you do meet a teacher, help them in their journey. That's what happened to me. I was helped by developers in the UK. There's no reason why this can't happen globally. And then create and contribute some really awesome libraries, which is kind of what you do already. Please make them consistent. So this is what I'm really excited to talk about. So thank you very much, those of you who voted for me. I'm now on the board of directors for the PSF. And so something that I want to do, I want to launch today, is this idea of a Python education work group. So I've set up a mailing list for this. And this in no way replaces education special interest group mailing list. That's really a mailing list for people who want to talk about education and pedagogy and so on. The idea of the working group is that we're actually going to make some of these things happen. We're going to make a new Python text editor. We're going to make idle better. Okay, so we want to make, it's for people who want to make practical contributions to that, right? We're not just going to sit around talking about it. Obviously, we will talk about it, but we're actually going to make things happen, and that's really important. And I need your help to be able to do these things. So I need you. And so we're going to have, specific goals that we hope to achieve. So before I can get this group recognised by the board, I'm really hoping some of you will join it. We can determine the governance and so on, and kind of talk about what it is we want to do, and then I can take it to the board, who already know I'm doing this, so we can get it officially recognised. So I've got homework for you all. Once a teacher, always a teacher. Number 1, join the mailing list, right? That's the first one. You're all taking pictures of that, which was really good, so I'm hoping you're going to join. Number 2, so at the education track at PyCon in Montreal, a guy called Al Swagger gave a talk called IDLE Reimagined. Unfortunately, I wasn't at that conference, and they didn't show those talks on the education track, which was a real shame because it meant I couldn't watch this talk. But I've heard about it, and I've been onto his GitHub where he has a wiki about it. I don't believe in duplicating work. I think this should be our starting point if we want to change IDLE. Your second point is to go and look at that wiki and get involved. And then thirdly, I think everyone should read this book. It's called Python in Education by Nicholas Tolove, who is here. It's a really small book. I believe it's free. It's an O'Reilly book anyway, so you all got a voucher, so you should just go and get this even if it's not free, and you should read it, because it really does help explain about Python in education. And so this is all due for next year, so make sure you write this in your diaries and your planners. I will be checking. And so lastly, I just want to talk about the future. There is a real danger at the moment that becomes an education fad, right? Code.org, Hour of Code, all those things are great, but I've met a lot of teachers like, oh, I've done coding. We did Hour of Code last year. It's like, well, you're not teaching programming, you're not teaching computational thinking, you've done an hour of code. Like, let's ensure this doesn't become a fad thing. There's a real danger that visual programming will just be the tool, right, that Scratch will continue to be used all the way up to kind of 16-year-olds. We need to make sure that doesn't happen, and we introduce text-based programming earlier. And really, it should be Python. I think there's a real danger at the moment if we don't fix some of these barriers that actually JavaScript is going to win. I had a really awkward conversation in the States with a guy who's developed a tool for teaching programming to children using JavaScript. I said, and he also has like a Blockly interface. I was like, oh, why don't you have a Python interface as well? And he was just like, well, no, because nobody uses Python, and children just want to make apps. Oh, no, they don't just want to make apps, because they want to put them online and share them with their parents. I don't think that's true, actually. I think that they could do some meaningful work with Python. And let's just consider if we are successful with what we're trying to do at the moment, which is to educate children and to get them thinking computationally, be able to solve problems. We could really change society for the better, and I truly, truly believe that. Think about all the children, reading, writing, arithmetic, those are the 3 R's. It could be the 4 R's if we, Raspberry Pi. It's a bit of a Raspberry Pi plug. But really, computer science should be as important as reading or writing. So given all that, in 20 years' time, when the Raspberry Pi generation are older, right, we've taught them Python, we've taught them, how to think in this way, they're going to go into all sorts of jobs. They're not all going to be developers, right? They're going to go into medicine, they're going to go into government, they're going to go into the military, they're going to go into, research. They're going to go into so many different fields. They're able to solve problems. I think it could be a really interesting place about open source as well. My mind is just blown. Those children could make this planet an amazing place. And so I think we should be excited by the future. And just one last thing. Just out of the blue, I had an email from one of my ex-students yesterday. And he was telling me kind of where he was after his A-levels. And it's a really bad time for kids at the moment who've just left school, who haven't had the benefit of this computing education, who have like ICT kind of qualifications. He's really struggling to find a job at the moment, like really struggling. He really wants to work in this sector, but he can't find a job because A, he has no experience, he's not been to university, and he wasn't taught computer science at school. So he's trying to do some kind of online tutorials, teach himself, but really he needs a foot in the door. So if anyone is in London, right, and this kid is really bright, really smart, he's just brilliant, he'd pick things up really quickly. If anyone can help him get a foot in the door, even in a free internship, I'd be really grateful, so please come and speak to me about that. But really think about how we can help young people. It's not a great time right now. We're hoping to fix that with this, these curriculum changes and this wave of computer science. But right now, there's this kind of middle group who can't get apprenticeships, who can't get jobs. He told me he went for a job interview as a delivery driver and he didn't even get that. So Yeah, so this is me. Please connect with me. I'd like to thank the organizers of this fabulous conference for having me. I'm having the most amazing time in this beautiful venue, this beautiful city, in this beautiful country. Thank you so much.
Thank you, Karian. If there is any question?
Stunned silence.
Hello, great. So thanks for doing this. We've also been teaching kids with Minecraft Pi, and it was pretty cool, but the problem was we had to download the tutorial, edit the HTML source code to translate it.
Right.
So if you can do anything about these tutorials, please make them translatable. You don't need to do it yourself, but please provide these options.
Yeah,
thanks.
We're working on that one. Just so you know, we are working on that. But thank you.
Any other question?
Hi, I noticed you mentioned something that I've heard a lot of times from educators, which is that laws or education boards or parent groups make lots of things with computers really hard. For example, the rule that you can't have an account under 13, or incredibly strict firewalls that are usually also broken in school systems. I once heard a story about a school where all the computers were locked in a safe because they were so afraid that they were stolen or maybe used.
Yeah.
What can we do about
that? So the kind of only way is to get educators change their mindset. Right? So having conferences like this where we invite educators along will start opening their eyes, because it takes a teacher who is willing to break the rules to change that. Right? If I had gone to my headmaster, if I'd gone to my senior management team and said, well, this guy from Cambridge is coming and we're going to make music, is that cool? They probably would have said no. Right? But so I always have this kind of argument that it's always better to ask for forgiveness than to ask for permission. And actually what we need are those superstar teachers. We need to find them. We need to help them break the rules. And at the moment, I feel like that's the only way we're going to change that. I think governments need to invest more in you know, not just the equipment that's in schools, but the infrastructure. I think the infrastructure is more important. Right? If we want to use these online IDEs, we need to change that. And I'm not sure what the answer is to that, because governments at the moment just strapped for cash. They can't improve those systems. So that's a problem. But I think the only way is finding those educators. Sorry about my joke about the IDE, by the way.
Hi, thanks for your talk. It was wonderful. So you said you named a number of problems that you have with IDLE specifically, and that you're looking for alternatives. Now, the canonical answer to making Python interactive and accessible these days is the Juniper Notebook. So what's your experience with that, and like, do you see any ways to make that more accessible for children specifically? Yeah.
So I mean, we could be talking about Atom right now, right? There's a whole bunch of things that are already out there. It's like, well, how can we just take something that exists and make it slightly better? But I think actually we completely simple that is designed specifically for education. Right? I don't think we should be taking systems and things that exist out there already, which are used, you know, for other purposes, and just trying to rehash them. I think we need something its main purpose is delivering Python in education. So, you know, there's a whole, like I said, there's a whole bunch of tools we could use, but that's not really their sole purpose. And I think if you start from that point, that actually you want to help an 8-year-old get started with Python, that there is a simple tool that they're able to use.
Any other questions? Okay. I'm sorry, we only have one mic, so it's going to take a little while to reach all of you.
We're keeping you fit.
I'm not going to run too.
With respect to IDs for education, we all know that to grasp well a full-fledged ID is a difficult task for beginners. Then what has the educational edition of PyCharm that you said that is applicable to use in education instead or in place of IDLE, for example, that it is the most simple IDE that we have for Python?
Yeah, I mean, it's simple to you. When I've installed it and tried to get started with it, it wasn't simple for me. I found there was a whole bunch of windows I had to get through. You have to create a project and open the project. That's a whole bunch of steps that actually, if I was doing a class full of children, okay, this is the first step. You need to click here and do this. This is the next step you need to do. That's a whole bunch of time wasted when actually what I'm trying to teach the children is computational thinking. The language is kind of second to that. I'm not specifically teaching them Python. We're using Python because it's such a great language, but the goal is not to teach them Python, it's to teach them to think computationally. So I'm losing a whole bunch of time in my lesson. I've only got 50 minutes in my lesson to setting it up and getting them started with. I also have to download it and install it, which in a school system is not as simple. I have to get the network administrator on side, they have to create a package, and they have to apply that to everything. Obviously, I come from Raspberry Pi. I would like something that was lightweight enough to run on Raspberry Pi, and we've had a go with PyCharm Education Edition, but it's perfectly. So I think there's just too many opportunities for failure with that for very young children who will click on everything and press everything. And as a teacher, I need to find time to learn how to use that application when I'm already trying to learn new skills to teach this curriculum. That's where the problem is.
So last question. Waiting.
Hi, thanks for the talk. It's terrific. It's just amazing. Thanks.
Thank you.
About that curriculum, so you mentioned it works in England, Estonia, Australia, New Zealand, Israel. What about other countries? So what is the problem? So if there was some experience, for example, countries from so-called Arab, like from, I don't know, Ukraine or Africa or, I don't know, any other countries, if there are some communities or foundations who are trying to reach you and ask how to do it, what were the main problems, how do they struggle with things?
So I really do think at the moment this is a global movement. Just because it's not written in the curriculum, for example, in every country, don't think that it's not happening. We know countries in Africa, like Guyana, who are kind of rolling stuff out, just not officially with an official curriculum. So what's really important to know about our curriculum is that it applies to state schools, right? Publicly funded schools, but for example, we have a whole bunch of schools called academies, which are funded by private sector. They don't have to use this curriculum if they don't want to, right? Don't think that we've solved the problem in England. And I do think in other countries this is already starting, and I think if schools or code clubs are a really great way to start, right? So if you helped run a code club in a particular area, that's where teachers start to see the effect it's having on their children, and then they're more likely to teach it, and then it will kind of snowball from there. It takes governments to change curriculums, unfortunately, but I think teachers can kind of push that a little bit.
Okay. So last question, and then we will thank Carrie Ann.
Thanks. It's a great idea to get schoolers, children to train and learn with Python. As there are also a lot of other programs that have interfaces to Python. I learned Blender, for example, that you can model things, you have physics inside.
Yeah.
You can combine a lot of the lessons in school. Do you use Blender also to show up?
So we have teachers in England who are using Blender, yes, for exactly that, to teach a whole bunch of stuff. I really think computer science and computational thinking is cross-curricular, right? So the stuff we showed you with Minecraft, you can teach maths with it, there's coordinates and so on, you can teach physics as well. Yeah, and Blender is a really great tool, again, free and open, right? So that's exactly what we want. Yes, it's great.
So thank you, Carrie Ann. A big round of applause, please, because she really deserves it. And yeah, you just go talk to her after the talk. There's a coffee break. Enjoy it. Thank you again. Can I help?
Hello, hello. Oh, okay. But then you try it a bit.
Hello, hello.
Sí, ¿no?
Hello. Okay.
Ahora sí. Hola. Sí.
Si necesitas cualquier cosa, para que le hagas una señal a él y él es el que controla. Perdona, ¿estás tú de...?
Does it work? ¿Funciona? Sí. Everybody, let me introduce you to Fabian Kreutz. He's going to give his speech on unit testing and TDD, the why, the how, and the when not. So go ahead, please.
Okay. Yeah, okay, welcome to my talk on unit testing and TDD. Testing is an important subject, and there should always be, on every conference, lots of talks about it for all programming languages. On the other hand, there have been already a lot of talks in a lot of conferences, and I don't know if I can say something truly original about this. So this talk is aimed mostly at beginners in testing, but also for people that have tried testing a lot and somehow struggle with it, found it difficult to adopt, are simply dissatisfied with the success that they have with it. The general structure is the why, the when not, and the how. Note it's a bit different than in the title. It just sounded better in the title. And let's start with basic reasoning why we would do testing at all. And the thing is, what do we do as coders? We read a lot of code, and we read a lot of code, and we just continue reading. And only after reading a lot, we will also write some code. And usually the point at this time in any presentation is the code should be readable because we read it much more than we write it. But I want to add a third thing that we always do, and that is the trying out afterwards. Run the code and see if it actually works. I hardly ever commit any code without at least trying out, without looking at it at all, because when I do, I always manage, even in a single character change, I always manage to put in some new error. So at least I try to compile it, I run it. In some form, it has to be done. And when this phase of baby steps, baby sicknesses is over, and you know your code runs, then you feel like Dr. Frankenstein. It's alive, and you'll be really happy about that. And a very important thing is you can be your own beta tester. You simply get a feel of how the code works. And unfortunately, all future techniques that I will build on now, everything like automating tests and TDD, will not give you this. But I'll come back to that later. One of the dangers of maybe trying out is shotgun programming. As humans, we tend to try to keep the thinking at a minimum. And I catch myself frequently that instead of really thinking how to solve the problem, I just try it out. Oh, it doesn't run, then I wiggle some variables, try it out again, and I just continue this without actual thinking until it looks good enough. The other extreme is maybe a little bit older. At the time of punch cards, and maybe nowadays, if you have a slot at time slot at a supercomputer, I'm sure you will think for hours over your code to make sure that the one shot that you have at running the code will be successful. But what is the right thing to do? Should it be a lot of thinking and hardly ever trying out, or should it be a lot of trying out and hardly ever thinking? Let's get back on track on the why. Let's automate. And trying out is nothing really else than automated trying out. And computers are very good at doing repetitive tasks. And especially when the setup is expensive. I imagine that, for example, you have to go manually into the Django admin or into an SQL console and tweak some records and remove all the traces from the last test run. Then you go to your actual application, click a number of buttons to do the manual testing, to do the manual trying out. And I bet with so many steps in between, you occasionally will just make some errors and you have to start again, go back to the SQL console, remove all the traces, return to that state. And automating it, scripting this part is definitely worth it. The problem with documentation is that it outdates. And tests, good are very good documentation, which automatically raises an alarm as soon as it outdates. So when the code changes in some form, the test will break, and maybe you decide, well, this test is actually outdated. I'll change it or I'll remove it. Okay. This is a bold statement to say that reusable and modular. People say that, but how does that happen? Oh, this is a bit too big now. Well, I hope you can still. This code snippet, it does what it's supposed to do. So it normalizes the input key and then checks if that key is in some cache storage. Otherwise, it will return a default value. So we are done, right? I mean, the code works, it does what it's supposed to do. But it's really hard to test. Why is it hard to test? Because it uses a lot of outside dependencies. And one thing that you usually do is you make dependencies injectable. In this case, you would move the store from the functional scope that we have here, one scope further up into the object scope. And then the test can easily inject those dependencies, and the function accesses it through the object scope. Another thing that you realize when doing tests is the standard dictionary has a get. The get of the standard dictionary accepts an optional parameter for the default, and that's a good pattern. And in this case, it also helps with testing because you can simply put it as an additional parameter into the function call instead of having to mock the get default function in the object. And then, while testing, you might also realize that this normalizing of the function is really its own, the normalizing of the key is actually its own functionality, and you might want to extract it so that you can build targeted tests for this one and targeted tests for the getting out of the storage. So what testing really does is testing reuses your code, and by trying to have small test cases, you are reusing it bit by bit. And in order to make your code testable, you have to make it reusable and you have to make it modular. So testable code is good code. Let's get back and see what happens if we don't just write a few tests, just maybe the happy cases and maybe one thing, but really a comprehensive test suite, which means that you try to go through all the error cases, you try to obtain as much code coverage as possible. Well, as I just said, if you care for all error cases and for all branches, then your code becomes more robust. Because it's not a thing that you normally try out. Some things are even impossible to try out through the UI, but they still somehow happen due to mysterious circumstances. And in automated tests, you can produce these weird circumstances, and that way test all cases, which makes it more robust. And once it's more robust, you have protection against regression. And only comprehensive test suites give you that. Just a few tests here and there are no protection against regression at all. And regression is maybe a thing when you change a small function somewhere, if you work on a single ticket. But my favorite thing is that I'm very dissatisfied with one module. I go into that module and turn it completely upside down. I refactor the whole thing. And if I have these comprehensive test suites, then I can be sure that my changes, then I can check afterwards what effect do those changes have on the other parts of the system. And I have to say, this feeling, that is the best feeling that I ever get during my development. I'm just happy when I see that. So, okay, you say, I write tests, but afterwards. So why even bother with TDD? What's the point in moving the testing in front of the development? Well, there are some risks in testing, and what I have written so far, what I have said so far, you can find it in any book, but the books maybe don't mention all too often also the risks. And especially because accomplished testers don't really have these problems anymore. An accomplished tester might say, what kind of moron says that he's going to make tests, but then is not doing them? In my experience, it just practically happens that out of all kind of reasons, not being clear about it, sometimes just being lazy, you're not doing it. We can assume maybe, people have talked about it often enough, that writing good tests is profitable because you gain more time than you lose writing the tests. You will not only write good tests, you will also write bad tests, and that also takes time, which you don't get back. And in fact, once you have those bad tests, you will pay interest. You pay interest to update them, or you pay interest to live with them. And while I just said that tests make refactoring possible, they also discourage refactoring. I once had, I had extensive tests on my views, like 120 test cases on the views. And the test relied on a certain way that the views set up the initial data. But that way, how they set up, that was just deprecated, and I wanted to change it. So I wanted to refactor it so that the views get their setup data from someplace else, but that would break all the tests. So it took quite some time. I postponed it a lot because I was simply afraid of breaking all the tests and having to rewrite all this stuff again. And with all things, if you simply don't do it right, then you don't get the benefit out of it. I said the benefit of good test names is that they document. If the test names are not good, then they don't document. And this has something to do, this has something to do with the robustness of the methodology. Testing itself doesn't seem to be robust because the worse you do it, the less benefit you get. A robust system would be, well, you do it halfway correct and you still get good benefits, but that's not the case. I've been talking about shotgun programming. Shotgun debugging is the scaled up version of it, that you don't really have to understand the code at all. There's a bug somewhere, or you have to add a new feature. Test break. Well, you just wiggle variables so long and you run the test and wiggle variables and run the test until it works. No thinking involved. So, yeah, as I said, this is a question about robustness. And moving now the testing from after the development before the development, it doesn't solve those problems. But I have found out that it gives us a certain amount of control over them. So laziness and time pressure leading to not writing tests. Actually, TDD doesn't help so much with that. You can just as easily not write tests beforehand as you can not write tests afterwards. But then again, postponing the testing until a time when the developer has somehow found closure, when the thing is done, that maybe is just not the optimal time to put their testing in the process. So maybe TDD helps us a little bit. I show that by some arbitrary number. This is really absolutely arbitrary number. It just says, well, maybe it helps us a little bit. It gives us a little bit of control. Bad tests. Whenever you do two related things, then you do the one that you do first, you do it twice. So when we do test after, then we do the code, and while doing the test, we go back to the code and update it a little bit. And there we have actually the thing that tests help improve the code quality. On the other hand, if we do the test first, and the coding after, then we are working through the tests twice. Once when we write it, and once when we are actually doing the code. Sometimes maybe we realize, oh, the test was a bit wrong. So which one is better? And I think that we have to see the priority. The most important thing about code is that it runs correctly. The second priority of code is that it is of good quality. This is maybe weird for developers, but in the economy, it is in fact so that if you have running code, independent of the quality, maybe that is the time when you start making money, and that is necessary for anything to continue. And also, we have processes, we have refactoring, and the tests help us a lot to later update the code quality to become better. We have the tests to help us in the refactoring. On the other hand, it is not priority one of tests that they just pass. It's not the objective that we have many tests that pass. The objective is that the tests are of good quality, that they are testing exactly what we want to do. So I say the most important thing at the time of creation is that we are thinking about tests twice. So we do it first, and then we think about it again, ensure good quality, because unfortunately there isn't really this third instance, the other thing which helps us refactoring the tests. We are a bit on our own on that one. So, back. I would say that gives us TDD gives us quite a lot of improvement on this one. And for refactoring, TDD actually is the answer, because what you don't want to do is what I do in the test after mentality. What you do is that you first go into the code, you refactor the code because it's bad code, and then you break all the tests. Well, okay, and then you go into the tests, and then you change all the tests. But not only is this dreadful work, also you're losing all the benefits. The tests don't help you anymore. They don't protect your refactoring. So literally the solution to this one is think the other way around. Think test first. Go into the test first, refactor the test first to do both the new and the refactored version of the code, and then afterwards refactor the code. And that way you are protected all the way through. So, even more imaginary point on this one. And with test, it's the same thing really, because when you are testing first, then the very first line of code that you are writing is the test name. So the very first thing that you do is, when you start, articulate what you are going to do next. And that's how you get good test names. On the other hand, if you have the test after mentality, if all your code and you just copy-paste a lot of test cases, then you just have to fill a void with necessary identifiers. The compiler says, well, those tests need some name, and you just say then test 1, test 2, test 3, test 4, test again, and so on. So I would say TDD gives us even more control on that one. Still two points that I skipped so far. And, well, they are really difficult. You need understanding. You need to understand your the requirements in order to do this well. Said about shotgun debugging. Shotgun debugging is the opposite of understanding. It is the not thinking. So TDD helps us with thinking, because it focuses on the what and not on the how. In fact, I would say when you are at this place that you want to write a good test as the first thing, you can't really do that without understanding what this is about, because you have to formulate a test name, and you have to create. You have to create the what. You have to articulate it not only in the name, but also in the test code. And at this time, your understanding becomes deeper. On the other hand, unfortunately, it is possible to just put there some code which seems to be like maybe what the customer wants. It is always very easily possible to just put some tests afterwards which pass. Writing tests that pass is very easy, but that's not what we want. So the control that TDD gives us here by, well, as in Germany we would say, understanding helps you to overcome your inner pig dog. But let's have a small intermission. Why is testing especially good for Pythons? In some, unfortunately, I didn't write down the source, so I can't give you the source. But in some, I saw like 9 or 12, a matrix of 9 or 12 of these kind of diagrams which plot efficiency that you have in a language as a function of the experience that you have in the language. And I distinctly remember that there was a significant update in a spike in efficiency due to unit tests. And I was wondering, and I mean, it's true, I felt this myself, but why is that so for Python and not for all the other programming languages? In my opinion, one of the reasons is Python has problems. And that's absolutely fine, nothing is problem-free. We need to have solutions for those problems. And one of the problems that is very often mentioned with Python is the dynamic typing. Especially Java and Haskell programmers might not even try Python because they say, dynamic typing, can't really work well. My compiler checks against that. Does everybody know what dynamic typing means? Or let's ask, who knows what dynamic means? I think that's almost everybody. I'm a bit short on time, so I'll continue on. So what is it that Python programmers say afterwards? They say, it's not really that bad. So who is right? Are the Python programmers just biased to see their own faults, or are the statically typed proponents just not seeing the light? Well, in my opinion, unit tests help alleviate the problem a lot, because comprehensive unit test suites will help you go through all branches of your code, and that's why they will execute all type errors, they will execute all non-exceptions, and they will fail on it. I have realized that myself, that I am actually suffering from the dynamic typing. I am producing a lot of these type errors in my code. It's just that during the trying out, I find them very quickly, and they are not a problem for me anymore. So okay, the Haskell compiler and the Java compiler, they solve the problem systematically. But unit tests, they do it well enough for Python. Another thing is the Haskell compiler does it for free. Unit tests are not free because you have to write them. But then again, you anyway want to write unit tests, so they are a free side effect. Another reason are the great frameworks, and at the moment that's especially Nose and PyTest. There are lots of talks about PyTest, especially also here in Bilbao. So I'm not going very deep into this, but there's one thing that I want to mention as the difference between JUnit, which I don't hear so very often. So JUnit is object-oriented, which means that we have a base class with all kind of generic assertions. And then we have lots and lots of test cases, which have a setup and a teardown, very special assertions, some helpers, and then maybe lots of test cases. So in object-oriented programming, we try to encapsulate many things into one class. Things that belong together, they go together into one namespace. The thing is that for tests, it doesn't really seem to work, because we have, on the one hand, the functionality, and on the other hand, we have the state in which the thing is. So, for example, if we have some list implementation or some stack implementation, we have different functionalities, like getting the length, appending something, popping something, and we want to have test cases for the setup when the stack is empty, when it's at capacity or filled. So how do you organize these in an object? Either you organize them by functionality, then you can't use the setup. Then you can't use the setup provided by the test framework. Each test function has to do its own setup. Or you organize them by state, which means that you have to put widely different functionality into one object. And where do the helpers go? The helpers must be somehow mixed in from the outside. And mix-ins work if you have multiple inheritance and if your language allows mix-ins. I was working in a project, this is not from the project, but in that project we had to write a diagram in order to find out how to write the next test. Okay, I have to speed up a lot. PyTest is the answer. There is, it has a more function-based approach instead of the object-based approach, and that helps a lot. Okay, the when not. I'm sure that if you had some frustrating time with tests, you would like to have a certificate like this. You want me to give you now a direct reason, which hopefully is exactly your reason, and from now on you don't have to do any tests, you don't have to put any work there. But it's not that easy. The general thing is that if it doesn't work for you, improve it until it works. But what I don't like about this is that it doesn't mention the costs. And it's an economic factor. We have to see, we have to measure how the costs against the profit. And maybe it's really high, and maybe the costs are low, but the costs are something that we have to be and that we have to mitigate. We have to first find out where are our costs, first reduce them, and only then we should try to improve. Where do the costs come from? They come from mismatches between TDD and other things. The first mismatch might be you. It's not common school practice to throw little children into the deep water because that's the way how they swim fastest. Unfortunately, in corporate culture, that is the case. So you are a developer, you start with TDD right now. And I think that's the reason why managers don't think that testing is a good thing, why they don't get that feeling. Because it's simply not, you can't just turn it on and it starts laying golden eggs. Well, luckily we have a good argumentation here. We agree that having good tests is what we want, and we have to write tests to have the good tests. But writing them also gives us bad tests. And now the good thing is that the more we write, the more we learn to write better tests. But now the problem with this is that learning is a human experience, and you can't learn. You cannot learn too many things at once, and you do not learn at all if the problem is too difficult. And now we have a new concept, the difficulty. I don't know of any metric, but I'll give you some examples of things that are very difficult. So framework subclasses like Django generic views, maybe, you know, where the class really is a combination of class variables and mix-ins. Those are really difficult to unit test. Anything asynchronous is very difficult. Simulated environments like a mobile platform, where the platform on which you are developing is evolving and you have to mock a lot. Abstract subclasses evolve in quite often before I really know what they are supposed to do. They become useful already. I generalize without really having a good name for that thing that I'm producing there, and that makes them really hard to test. And everything that has high interaction means a lot of mocking, and a lot of mocking always means a lot of complexity. Another thing is that if you read a TDD book, you get the impression that TDD is all that you ever need. You just one on, and then everything works fine. But what is not said there is that you need to have a process around it which fits with that. So you need a specification gathering process, which is maybe in your company done by non-technical people. And especially, you need an architecture around it. And the architecture also needs to fit with TDD. Because if you do TDD alone, ignoring the architecture, you will always build something which breaks apart at iteration 3. The team has to be on your side, because doing it alone just doesn't work. If you have a customer that you can educate in your process, great. But if you have an ever-changing customer, it's simply not worth it. So you have to compromise between what the customer gives to you. Maybe the customer gives you only very vague things, which simply doesn't work with TDD at all, because TDD requires you to have very good specifications at the beginning. Now, I'm not saying that having good specifications at the beginning is a bad thing. Definitely not. You want to have that. But if you don't have to, you might have to compromise. Then there are spikes. I'm sometimes going off to little programming adventures, and that code might become really big. But it's I'm starting really on an adventure without a plan, not knowing where, and then TDD is simply impossible. So in the end, I would say it's everything is in a relation. You have to see, is your competence good enough to tackle the difficulty, and can you alleviate the uncertainty? If not, if you which is simply too difficult for you to test, then don't try to bite it until your teeth fall out. Maybe skip the test on that one and test something else first until your competence grows enough, because it will always grow. Nobody ever finishes. Nobody has this competence where he can test everything. But you can also see that there are 3 people on one side, and the process is for hire. So if you can get the process on your side, there are 4 people on your side, and that should give you the bias that a lot of testing is a good idea. Okay, but how to do it now? We agree on the why, and we know that there are some costs, but how to go to the next step, how to work with those costs. One thing, this is mostly a recap actually, because I have mentioned already the tools, and it's very important not only that you use the right tools, but that you learn them beforehand. Don't start learning a completely new testing tool and a new testing methodology in the new project that you are building, which will involve maybe 30 developers. What you want is maybe a small experimental project on for yourself, maybe a tic-tac-toe game. And in that game, you try out everything, so you will learn all the dependencies and all the configuration of the testing tools. Don't try to learn too many things at once. Continuous integration helps you and your team with peer pressure, because it shows you everything. It shows you whenever somebody. The tests don't help at all if you don't run them, if you just write them and you don't run them regularly. Continuous integration will not only run them, but will inform the whole team by email, for example, if somebody breaks it. And you have to create a company culture in which nobody wants to be the one who broke the tests. And with peer pressure, it becomes fun doing it the right way. I also have realized, just do it. Just start with the first test. If you have legacy code and you test after, that's fine too. Just start with the first test. And while you're doing the test, you will realize, oh, by the way, there's this one error case. It's very easy I just copy-paste this test and change a little bit here and there, and then you have the second test. And then you realize, hey, well, it's just a few steps, and I can have really thorough tests, and you'll have a comprehensive test suite in no time. And never stop the trying out. I have mentioned at the beginning, trying out is a thing which gives you a feel. How usable is it? How performant is it? Does it make really any sense? I have just heard somebody tell me that he has written these great tests and everything was working with tests, but then when after a long time they actually started the application, they realized that half of the buttons were invisible because they didn't have tests on that part. I have mentioned these things which are very difficult to test, especially with unit tests, like interaction and asynchronous connection to third parties. And the point here is that functionality tests or integration or acceptance tests, whatever the name for that should be, will help you a lot. And that gives you behavior-driven development as the next step above. The names are sometimes used differently, but also I have seen in this conference which show you have the TDD process as the small one using small unit tests, and then you have the behavior-driven development cycle around that, which cares for the bigger tests, for the acceptance. So there are cases in which I don't do any unit tests at all because the functional tests will catch it. A unit, that is also a thing right here. What is a unit? I was very confused about this a lot because this name also implies somehow that everything is made up of units. So everything can be unit tested. And I disagree with that. There are some things which are simply not meant to be unit tested. You have to have tests on everything so that you know that the code runs. But sometimes functionality or integration tests are simply enough for it. If you want to create your test names, then think user story. As a storage module, I want to access the file system by doing this and that. And out of that user story, you can generate the test name. And as I have now mentioned a few times, don't be dissatisfied with your progress. Sometimes you see people that say, oh yeah, I have 100% coverage, I have 3,000 lines of code for tests, lines of test, and only 40 lines of code, and you get the feeling, oh, maybe I'm not satisfied with my testing, maybe I don't benefit because I'm not doing it extremely. I don't think that it is like that. So don't overdo, you will grow slowly, and the thing is, don't expect testing to be the thing that you turn on and then everything works fine. What do I mean with do it all wrong? I said already you should have this small testing project. You have a tic-tac-toe game, for example, and now try it. It's only maybe one file of code, and you write comprehensive test suites that have 100% coverage. Coverage is a tool which I didn't have the time to mention now. And then try out afterwards to introduce a bug that is not found by any of your tests. And that way, you will find out it's actually quite easy to do, and that way you realize how to write the tests. You can create a monster test case for all features that try to refactor, and you will find out that test is horrible. If you test too many implementation details instead of the overall API, your tests are really bad. I have learned all of these things by doing them in huge production projects, and I just wish I would have learned them in very small projects. So if this is all that you get from my talk, try it out beforehand. Don't try to do too much learning at once. And I reached the end of my presentation. And do you have any questions?
Thank you, Fabian. I'm very sorry, but we have no time for questions because we are running out of time.
Oh,
Thank you.
okay.
So is it working for you?
Rafael Piercina, who's going to do a presentation on coming to the dark side. We have a whole bunch of cookie cutters.
Yeah, so hi everyone. First of all, I want to thank you for your interest in my talk on Cookie Cutter. My name is Rafael, I'm from Germany, and well, I do love open source software and more specifically Python. And I'd like to say a few words about my background. So I'm not just yet a web developer in Python, but I do have a solid background in 3D animation. So it's a field where Python is actually used quite frequently. I am a core developer of Cookie Cutter. I worked on the Adobe PyTest month in April. And yeah, I did I was acting as a technical reviewer on a book on Kiwi, a framework I will talk about in just a second. More importantly, yeah, as I mentioned, I have the commitment to Cookie Cutter, and this will be going to be my main subject of my presentation. My GitHub username is Hackabrot, and I do have a Twitter, so please feel free to just shoot me a text with feedback or questions later on. As you can possibly tell from the title of of this talk, I like Star Wars, and I was more than happy to exchange ideas with our very own master, with Giru, just on a very philosophical question in a sense, for yourself. Yeah, so anyhow, the talk is about Cookie Cutter, and Cookie Cutter is, in a sense, a command line utility that helps you to start new projects following best practices of the Python community, simply based on templates. People may write for you, author for you, or you can just do it on your own. We are hosted on GitHub. So if you want to check it out, it's audrey.r/cookiecutter, and it's written in pure Python, as you can see from the blue bar. Yeah, so you can also find it on PyPy. We are currently at version 1.0, and we do have this quite large set of features, I think. So one of the best things about Cookie Cutter is that it's working on all platforms. So it's Windows, Mac, Linux, and Python 2.7, 3.3, 3.4, and also PyPy. We managed to add Unicode support for each of those platforms and the Python versions, which was quite and it's open source, obviously. So the technology is used. Cookie Cutter uses templates to create projects, which can be arbitrarily complex. So we use Jinja 2 for the whole templating, and we do support both Git and Mercurial. Almost 100% of the code base is covered by PyTest tests, and we leverage Tox just for testing all the different environments and Python versions, obviously. So about the community, we have a team of 5 right now, so it's Audrey, Daniel, Michael, Paul Moore, and myself, and we welcome everyone to just participate and contribute to the code base. Up to now, we are at 61 people, I think, but it may have changed from the time I developed this presentation until today. The people of you who are working on Django might know those people. This is Audrey and Daniel. They are the authors of two scoops of Django. They just recently published the newest version targeting Django 1.8. Yeah, and this is them celebrating the 10th birthday of the Django project 2 weeks ago. Something about the history of Cookie Cutter. So it was, in a way, born at EuroPython in Florence 2 years ago. So this is a citation of Audrey. So when they came back from Florence, they were like all pumped up and wanted to sprint on open source. And Audrey had so many scripts flying around that she was actually thinking of being very useful. So she wanted to publish them. But every time she was facing that, she was doing the same work over and over again. And this eventually was the moment when Cookie Cutter was born, because she said, well, why not just have a template for it and focus on the production logic itself instead of just setting up a setup pie all the time. That's just plain stupid. Yeah. So she decided to dig into templates and learn Jinja 2, or get the deeper knowledge of that. Yeah, and it wasn't until, I think it was May 2014, that I started contributing on Cookie Cutters. A very simple template at that time, and you see there is like a spike. So the next contribution was in November. I had like this a bit of a crazy idea, so I wanted to learn PyTest or get more knowledge of it. And well, I said, well, they have a code coverage of almost 100%. The code is very, very clean. So why not just transfer the whole code base of Python tests to just PyTest? And that's actually what I did. It took us, I don't know, maybe 60 days. And right now, with the latest release, we are at pure PyTest, and it worked out perfectly fine. So this was ultimately the reason when I was promoted to get the commit bit, I think. Yeah, so in this presentation, I want to show you just how easy it can be to author a template for Cookie Cutter. And I'm very, very positive that Cookie Cutter can be used in various occasions, regardless of the field that you are actually working in. In the following, I'm going to explain you how to author a template from scratch. So for this presentation, I'm also using like a framework for natural user interfaces. It's called Kiwi. So my question to the audience is, how many of you actually know Kiwi? Okay, that's actually quite a bit, yeah. So even Guido recognized Kiwi, so I think he mentioned it on PyCon 2014 last year, and he emphasized that people should start contributing to the project. Sadly, as far as I know, no one from the core contributors is here right now. Yeah, but the best thing of Cookie, you can just write Python code for your mobile. So I think that's just pure awesome, and I think the only person disagreeing to this may be the poor guy from yesterday. So it was an amazing talk, but still, yeah, I think we should do more Python on mobile devices. So the first thing what I do when I start a template from scratch is usually just creating a project in GitHub, because it's just having features that you really want to leverage. It's like creating a git ignore for Python files that has a README already set up for you, and you get a license file for free as well. So next you want to, so those of you who are familiar with templating with Jinja possibly know the syntax already. It's like using two curly braces, then some kind of domain and a variable name. That since I want to use the repository name for both my project, but also for my Python package, I'm using the repo name for both of these. And inside, I'm just creating 4 files. One is an init to have a Python package, then a module for my application. Then I have like a Kiwi file. Kiwi uses its own very language of describing a user interface in a very declarative way, so it's very, very easy to do rapid prototyping and such. But it's totally optional, so you can write your user interface programmatically as well, or you can just combine it. It's up to you. And then I'm using a file called main.py. So when you decide eventually to deploy your Python application to an Android device, for example, there is a tool called Kiwi Launcher. It's in the app, in the Play Store. And it enables you to just run Python source code without like compiling it. So you don't need to create an APK for it. You can just run it to the Kiwi Launcher, and it will just work. Yeah, so inside of my init, I do a bit of like, what's that? It's meta information about my package, and I'm using like a full name, an email, and the version. Pretty standard, I think. Next, this is the module for the application itself. Kiwi does this thing in the very beginning that wants you to specify the version of Kiwi that you are using. It's just like a safety switch that when you're using a very old version and you try to use Kiwi features that are not yet available, it will just raise a proper exception and you know what it's about. Then we inherit from and we simply set up the title, and the build is a standard way of, so it will automatically detect the Kiwi language file and return whatever inside there. And this is actually one of the main features of Cookie Cutter. You can use it for every programming language or markup format that you can think of. It's just, it needs to be readable as a text. So yeah, I think that's one of the best features about Cookie Cutter. Next, main is just running the application. That's basically it. And as I said, it's one of the easiest way to deploy your Android app. So this is a Kiwi file. Again, it requires you to just version that you want to use, and this is like a root element. We want just to have a button and a text, and the text of the button should be the application title. As I said, it's optional. You can do it in source code, just as you prefer. One of the most important things about Cookie Cutter is it requires you to do 2 things. One of which is having a called Cookie Cutter JSON. You specify all the variables inside there. And the next one is to have a folder that's actually templated. So that's basically it. That takes you literally like 30 seconds to have a Cookie Cutter template. This is how a Cookie Cutter JSON looks like. So as I said, you just mention all the variables that you want to use throughout your source code. I'm using my name or the author's name, an email, an application title. I'm using an app class name variable. This is specific to Kiwi, so I was thinking it might be very helpful for me. A repository name, a version, and the Kiwi version. The values are the defaults. So when you're prompted on the command line for entering those values, this will be like the default that's shown to the user. Yeah, so talking about advanced usage. What you can do with Kiwi is you can template your variables inside of the JSON. So there is a best practice in Python that you're possibly familiar with, that you have like a project name which is human readable, then you have a repository name which is just all lowercase with dashes, and you usually use all lowercase without dashes, just pure letters for your Python package. So this is not exactly what I've been showing here, but what I'm using here is that I'm using the application title. I replace every space with just an empty string, so it removes all the spaces. And it adds an app, just the string app at the very end. The repository name should be all lowercase, and it doesn't have the app. Another great feature of Cookie Cutter is that you can have post and pre-generation hooks. So you simply need to have a hooks folder at the very root of your template. And inside you can put a shell script or a Python module, and it will be executed by Cookie Cutter either before the generation of the project or afterwards. So this is an example of a post-generation hook that I'm actually using. It's a bit of code, but the most important part is that you need to understand that Kiwi has its own way of detecting a Kiwi file language file. So what I'm doing over here is just that I'm using, by default, the application class name as a Kiwi language file name. But since the user is allowed, so there's no kind of validation that he isn't allowed to use an app, like the string app at the end of the class name, I'm just making sure that Kiwi, because Kiwi will strip, as you can see, it does the slicing thing with the last characters, lower app class name. So this is basically an adaptation of the Kiwi source code that's responsible for finding Kiwi files. So where are we right now? So we have, at the root of our project, we have a JSON. Then, as I said, the only mandatory name, you have a templated root name for your repository. We have a Kiwi file language, we have a module, we have an init, a main, we have a license file that was generated by GitHub that I just copied over from the root. A README, I usually use restructured text for that, so that's why it's not using the Markdown file from the very beginning. A hooks folder, and the license and the README. So I'm a bit into testing, so what I tried to, because there's no kind of way that's already very well established for testing Kiwi applications, I tried a bit, and I'm here for the sprint. So if anyone is kind of interested in testing Kiwi apps, I'm very open for suggestions and collaborating and maybe writing a PyTest plugin for that. So just approach me and I'll be very happy to collaborate. Yeah, but I did find a solution in the very end. I'm using it's just a part of the source code. Next slide will show you what's actually important. So I'm using the interactive launcher. It's a feature of Kiwi where you can change the application at runtime, so it doesn't block you from changing the code. So I'm leveraging that to modify my application eventually. So I return the application, and this is actually my test. So it will just receive the fixture from PyTest, which is one of the most incredible features that I use in testing frameworks. And this is my test. It's just a plain assertion, and I'm just making sure that the application title is actually what I specified in the command line prompt when creating the project. Next up, I want to have it as a PyPy compliant package. So I'm using setup.py. I originally had a couple of slides on that topic, but since we had so many talks on the whole packaging and distribution talk, I just included some of the most important resources for that kind of information. So the official one, then Jeff Knupp did a very, very great blog post, which has, I don't know, 1 million comments on it. And Jonel, who presented his packaging talk, I think it was on Tuesday, and he also referred to Cookie Cutter. So this is him, and he's actually one of the contributors for the templates, but also Cookie Cutter itself. So next up is Sphinx documentation. You always want to have like an auto-generated documentation for your source code. And this is actually a funny thing that you can leverage exactly the same thing. So I'm using the Sphinx Quick Start usually. It will do basically everything for you to get started. And I just literally feed the cookie cutter variables to Sphinx, and it will just put the variables inside of the Sphinx documentation. So afterwards, it will just be done, basically. Another feature of Cookie Cutter is to have a user configuration. So in your home directory, you can just have a Cookie Cutter RC. And what it does is it will, when you use Cookie Cutter and you use it quite frequently, you don't want to enter the same values over and over again. So when I'm running Cookie Cutter on my own machine, I pretty much know that I'm Raphael, and I do use this email, and my GitHub username is still the same. So what I do, I have this in my home directory. I specify those values, and it also features abbreviations. So typing, you don't need to type that much. Cookie Dozer is one of my templates that uses Buildozer to build the APK for Android. And I just have an abbreviation for that, so I'll show you on the next slide how it works. And another thing is just abbreviation for GitHub. So when I run this command at the very top, it just says, I'm referring to GitHub. I want to use a template of Audrey, and I want to use the Py package of her. And when Cookie Cutter is running, as you can see, it just clones it, and it asks me for the details. And it automatically sets up the values from my, I can still override, of course, but it will just predefine the context. Yeah, so I want to talk about features that are currently in development. We actually merged them already, but we still didn't find the time to actually publish them on PyPy just yet, but it's just a matter of days, I think. So next up is coming, we have choices in our templates. So it was requested by the community, and we also find it very reasonable to have choices in templates. So at the bottom, you see I can specify an orientation for my app with Kiwi. I can say it doesn't matter, it will be resized and auto-adjusted, but I also can fix it to being landscape or portrait mode. So when I run this from a template, I will be prompted by Click. I mentioned it in a talk, I think yesterday, that we use Click for all the prompting, and it's working really nice. So if any one of you wants to write a command line that's interactive, just use Click. It was working like a charm. So this is a prompt for choices. I implemented it in a way that it will just use indices for the choices, because users can put every text in there. So it would be very long if you need to type the choice. So I just decided to stick. This is an implementation for the Click prompts, because I didn't find any really great usage on GitHub for Click prompts with choices. So I decided to share my findings to you. So as you can see at the very bottom, I'm just using Click for a prompt. The prompt is set up up front. It's just as you saw on the previous slide, it was just strings and showing the choices. And the most important part is that you specify a type. You can also use Click Boolean, for example, so it will make sure that when you enter a value, it's really a Boolean. But for this, I'm using choice. So Click will do if you type in something that's completely awkward, it will make sure that it's repeated as long as you really pick one of those choices. Yeah, so talking about the community, I think we are doing a pretty good job at replying to pull requests and answering issues. So I really welcome everyone to contribute and submit your own template or even contribute to the code base. So right now we have 41 templates in total. Most of them are for Python, obviously, but we do have very various templates already, some of which I don't even know what they really do, but I think half of the Python templates actually target Django, so it seems to be a common case in Django applications to use a lot of code, so you may want to use a template for that. One of the most popular ones is actually from PyDanny himself, and they do have, I don't know, so many, so I think it's 700 stars on GitHub already, so it's used quite frequently. And it's not only Python code, obviously, it has all those languages inside. It's really a great template. It comes with a lot of features. I'm just not commenting too much on them. You can just check it out on GitHub on your own. Next up, we have Cookie Cutter PyLibrary. This is actually from Jonel, who gave the talk on the packaging topic on Tuesday. So everything he's been talking about. He wrote an amazing blog post on that topic, and he authored a template with all the best practices that he's using for his own work, and a lot of people seem to like it. So he has features as well, continuous integration, setup, talks, obviously. Yeah, and I actually want to have like a quick demo of Cookie Cutter for you. So just give me a second. Yeah, so usually what I do is I will just run Cookie Cutter in here. So what I usually do, as I already said, I use the abbreviations, but since the Wi-Fi is a bit flaky sometimes, I'm using just my local copy of my template. But there is a way of, also there's a feature, you can specify a flag with -c, which will automatically check out a branch of like a repository which is hosted on GitHub. So you don't need to clone it and change the branch on your own. You can specify it, and Cookie Cutter will handle it for you. So when I'm running this, it will obviously ask me for a name. And since, let's just pretend for a minute that I'm Harry. And I decide I want to write like a Python app that lets people meet on conferences. How many of you have been to the Lightning Talks just yesterday? Okay. Okay, so my application will be Pinder. So the application class name, as I told you, it will automatically update like the default value depending on the values that you entered before. So obviously I said I want to call my name Pinder. The app class name will be automatically adjusted. I will just stick to the default for now. The repository name, I'll just call it Fuba. The short description, let's say an app to meet squirrels, badgers, and mice at EuroPython. The version, well, it's in development still. Kiwi did an update just recently, so I should be on this version already. So, yeah, in the area. And what you see at the very bottom after replying to, this is actually my post-generation hook, so the template also features internationalization right now. So I support English, German, Spanish, and French at the time. I'm using GNU getText for all this stuff. So this is just me calling a makefile that handles all the library setup. So what I do then is usually I just go to the repository and I create a new virtual environment. I already to set up like the folder for the and I call it foo. So then there is a thing, Kiwi uses Python internally, and sometimes I feel like it's a bit of a struggle to set up, so I'm usually just doing it once, and I know it works, so I use the dependencies from this very virtual environment. So there's this command in virtual end wrapper that actually lets you use dependencies from another virtual environment. So what I do now is just calling Python setup by develop. It will set up an entry point for me, and I can run, what was the name? Pinder. No, that's wrong. Yeah, so here we go. We have a running Kiwi application, and it's, as you can see, it features the values that we entered. I'm afraid the the font size is a bit. So I'm just increasing the font size for the application. There we go. So it says like the application title, then the short description that I put in. It says that it's built with Kiwi, and I can change like the language during runtime. So since we are here in Bilbao, I'll just use the Spanish version. I'm not a Spanish speaker myself, so I kind of depend on my friends to not fool me and display very, very offensive stuff here, but it's, I think it should be fine. Okay. Yeah, so I was actually able to deploy it. I'm on a Mac right now, but I was using Ubuntu and it was just perfectly fine. Once you set up a tool called Buildozer, it's in the Kiwi namespace as well, it will handle all the packaging for an APK for you. Right now, Kiwi, as I said, it's for macOS, it's for Windows, it's for iOS, it's for Linux, it's for Android, obviously. But the support is by far just, I think Linux and Android should be the best environments for that right now. Yeah, I can also use the German version and just change like the speed in which the slides. It has multi-touch and it has gesture recognition, so I really recommend you just giving it a try and see if it works out for you. And it also has like, I can click, this is a link, so it will automatically take me to the repository. Yeah, that's it for the most part. Yeah, so I'm actually writing a blog, and in January I was publishing like a series on Cookie Cutter, so if you really want to dig into this topic, feel free to just, it's hackerbrot.de, and just find those 3 posts. They're all two pages long and quite, yeah, comprehensive, I think. Yeah, as I said, if you really like the artworks, please give my friend Anselm from Germany some kind of love. So I think he deserves some kind of applause later on. He did an amazing job on those graphics. Yeah, and other than that, yeah, thank you. As I already said, you can find me on Twitter and GitHub, and thank you very much for your attention.
Thank you very much, Rafael. Questions, please?
Hi.
Hi.
This project looks actually quite similar to Yeoman from JavaScript universe. Maybe you have seen that one. So I was wondering, have you looked at Yeoman and how Cookie Cutter it, and do you think it's worth it to have like our own Python version of that?
Well, to be perfectly honest, I don't know that project. But I think there are plenty of tools that already use templates. So there's Scaffold, I think, as well. We do feature them on our page. So there's no like, I don't know. We can still try to find a common solution, I think. Just yesterday, someone on Twitter said that he actually re-implemented Cookie Cutter in Go. So it seems to be a very fun thing to do. Yeah, just. I don't really know the tool, but yeah, maybe a solution that we should have a look at.
Yeah, thank you for the talk. I got a question, how do you handle updates? So if, for instance, I use one of the Cookie Cutter templates to create my project, and 2 months or half a year later realize that the template has now some cool new features in, can I just run it again and update my project, which has now a lot of code inside? Is this possible? Or?
Up to now, it's actually not. But it's requested by the community, and I mean, we are all full-time professionals, so we just didn't find the time to implement just yet. But we are very open to it. So as I said, it's requested quite often. So we still need to find a solution for that, and once we have one, so please feel free to just recommend anything or just submit an issue and we'll talk about it.
Okay, thank you.
Yeah.
Nobody else?
Okay, so maybe you want to give an applause to Daniel and Audrey as well. They sadly couldn't make it this year to EuroPython, but I think they did a tremendous good job on this too as well. So please do me the favor and just give them applause as well.
Thank you all for coming. Explain to us, NumPy vectorize your brain.
Hi. Well, let me get started. My name is Catherine, and I'm a PyCharm developer. And how many of you know about PyCharm? Oh, great. Well, this talk is not about PyCharm at all, so if you are interested in PyCharm, please visit our booth. We'll be really happy to see you there. And what I'm going to be talking about is vectorizing your brain with NumPy. And this is actually a lecture taken from my graduate machine learning course. I'm currently teaching at academic university in St. Petersburg. And how many of you are using NumPy? I mean, how many of you are using NumPy in your everyday development? Well, I'm sorry, guys. I believe I will not tell you anything new today. And as I already mentioned, this talk is taken from my machine learning course, and you might wonder why this talk was included in such course in the first place. And the simplest answer is here. I started my course with a simple algorithm one can imagine, and it's k-nearest neighbors. And this algorithm, you're probably familiar with it. It's used in classification tasks. And the idea is to assign the label which is most frequent among k-nearest neighbors to the object. And assignment for this lecture was to this algorithm and apply it to Wien's dataset. And that was actually an average code I got in reply to this assignment. And no one of my students actually used NumPy. And well, it was sad. And this code worked hours. I mean, I can just wait for so long time to check the assignment. So my teaching assistant and me decided to include introduction kind of lecture in the course. And well, that is my motivation to speak about NumPy and spread this knowledge. And NumPy is the main tool used in all the science. And what I want to do today is talk about how to use NumPy efficiently and how to use it for data-centric computing. And it's relatively easy, but you have to think about in some different ways about your code writing NumPy in order to use it efficiently. So I'm going to go through some ideas that may be helpful. Well, unfortunately, when I was preparing this talk, I found that I didn't have enough time to make proper introduction to IPython. So I'll assume for now that you're all familiar with it, but I will explain some features used in this talk during this talk. Well, let's get back to Python, and let's talk about Python performance. Well, the first thing a person learns about Python is that Python is fast. And it's fast for developing and trying things out. But unfortunately, the second thing you learn about Python, that Python is slow. And everybody knows that Python is slow, but do you know why? Well, any of you? So let's write a simple function to calculate Euclidean distance. And this is actually also taken from this first assignment. We need this Euclidean distance to calculate nearest neighbors. And on the first row, we got number of iterations needed, and then we just accumulate the distance or the difference between 2 points, and then return this accumulated sum. Nothing special. And I'm going to be using TimeMate Magic function included in IPython and IPython notebook. And it allows you to measure your runtime. And what do we do with this slowness? And that's where NumPy comes in. NumPy is basically designed to help us get the best from both worlds. We want to have fast execution time from languages like C. And we want fast development type from Python. So I'm going to talk today. Here is some ideas to make Python faster when you are working with numerical data. The first idea I'm going to talk about is ufuncs, and it's the simplest opportunity. Ufunc is the short name for a universal function. This is basically a special type of functions defined within a NumPy library, and it operates it element-wise on an array. And the idea behind the ufuncs is to combine functionality and the loop together, well, in one. So let me show an example of this. If you're a Python programmer who doesn't use NumPy and you want to do element, and so we have an array of int values, and we want to add one to each of these values. And as a good Python programmer, you probably use list comprehensions. So you do for value +1 for value in A and print out the result. So this is Pythonic way to do it. NumPy way to do this is to, which is a bit simpler, is to create NumPy array with special creation functions. And here we don't add 1 to the end of the array or something like this. What you do here is you treat your array as just a number. And NumPy overloads plus operator and actually produces a result element-wise. So that plus operator is doing here beneath the surface is binary U function. And universal function combines loop and functionality. So what we've said here is when we do A +1 is we tell NumPy I want to loop through all the elements of the array and I want to add 1 to each of those elements. And we have the same thing for multiplication and for other operators. And please note, this is element-wise multiplication, not just matrix product. We'll have nice syntax for matrix product in Python 3.5, not now. And well, notice the difference here. We do not have any loop here. So, with NumPy, this loop actually taken place in internals of NumPy. And the question is, why do we care about this? So let's take a look at the speed of ufuncs. First of all, we create a large array with a lot of values, and 2% in TimeIt function means to time everything in the cell. And we're gonna time creating an array and adding 1 to each element of the array. And for NumPy, what we get is 100 microseconds per loop. And if we do the same in pure Python, we do this by hand in Python. We create an array and then we loop through the length of the array and then we add 1 for each element of the array. And again, we got 100 factor speed up. Well, and also I should point out that it's much more easier to type and understand this code. It's hard to get it wrong than list comprehensions. And you might ask why why NumPy is so much faster? So what is the magic that happens under the hood in, well, here? And what it comes down to is the fact that when you use NumPy functions, The loops are happening in compiled code. So NumPy is a big package written in C, and you have compiled functions for common operations. So the common operations, we actually access these common operations in Python using the high-level expressions. And that's why it's so much. Well, does it still make sense? Okay. Well, it's really nice, these U functions, and there are many U functions that are built into NumPy, and basically all arithmetic operations, comparison, bitwise operations, overloaded for NumPy arrays to do this sort of universal functions element-wise. And there are a bunch of other operators in NumPy. Well, the next thing we're going to talk about is slicing and indexing. And if you used to lists in Python, you know that you can index list with an integer to find a single value, and you can also index list with a slice to get multiple values, and you can actually do absolutely the same with NumPy arrays. Well, and one interesting thing about NumPy slicing is that there is no memory overhead, unlike in plain Python lists. And NumPy returns just a view of the array. So if you assign this slice to the new variable and you change only one value in that new array, this value is changed in the initial array as well. So please be aware of this. Well, in multidimensional array, you can access elements by row, comma, column. So indexes. So if you pass 0, 1, and we are asking for row 0 and column 1, and that the value is 1. And we can also use slicing on multidimensional arrays. So in the last example here, we got a submatrix. And we can go further and combine slices and indexes together. And here we are asking for row number 0 and for all columns, which is exactly the same to write, well, 0 of x of 0. NumPy actually offers a lot of other fast and convenient ways to do all sorts of indexing, to index more complicated arrays, to index more complicated chunks of data. And one of those are index arrays. Index arrays is just basically passing indexes to the array. So if you want second, 0th, and first element of the array, we just put those indexes in a list, and we pass that list to the array index, and came up with the values. And again, we don't have to write any loop here and over these indexes. We just pass them all together at once, and it's much quicker to, than writing a Python loop. But the weird thing about this is it doesn't return the view of the array, as we've seen before. In most cases, it returns a copy of the array. So you have to be aware of this. You can see here that this assignment didn't change the value of the initial array x, unlike we saw it before. And NumPy allows you to use Boolean mask as an indexing. So instead of passing an integer to choose values from x, you can pass this mask. And it will construct the array you are interested in. And so this might seem like, why would I need a thing like this? And when it becomes handy, when you combine this with the simple U functions we saw earlier, and if you look at the last example on the slide, here we used x is greater than to construct a Boolean array, then we just pass this array to the array index of x. Well, and I found myself using this technique mostly on data preparation step. For instance, when we are looking on the array and we want to split data into test and train sets, well, the nice ways to do this, besides using built-in SciPy test train split, is to create a mask with the length of the array and apply this mask to the array and apply its negative version of it to the array. And that's how the same thing achieved by my students. So instead of writing this loop over the list and saying, for item in the list, if some condition appended it to the result, it happens automatically, and it happens in one line of code. And it's much, much quicker than this Python by hand version. And the next idea I want to talk about is using NumPy broadcasting. So this is something very cool about NumPy. And broadcasting is one of these things that really makes NumPy powerful and allows you to express very complicated operations very easily. And what broadcasting does, it gives you a set of rules by which it operates on the arrays of different sizes and dimensions. What this set of rules allows you to do is to do things like add integer to an array, and, well, you can add a row to the matrix, or you can do even crazier things. You can add a row to the column, and it will expand to the two-dimensional matrix. So the rules of broadcasting is pretty simple, but it's sometimes a little bit confusing, and it takes a while to wrap your mind around what's going on. But once you get this, you can do a huge amount of operations that really efficiently using these broadcasting rules. So the first rule is if the array shapes differ, left pad the smaller shape with the ones. And then you compare the dimensions, and if any dimension doesn't match, you broadcast or kind of expand the dimensions with a size equals to 1. And if the dimensions don't match, but neither of them is equal to 1, there is no way to match those together, and you raise an error. So this is a quick example of how it goes. We already saw adding a scalar to a vector example when we spoke about U functions. We didn't know back there that it was broadcasting. And looking at this example, we have 2 by 3 matrix, and we are adding length 3 vector. So the first thing we do here, we do left pad it with the ones to make the number of the dimensions match. And then we broadcast that up, and we stretch that vector across the whole matrix. So then we have 2 matrices to match. And then we just add them together, and we got the result shape 2 by 3. And we can think about it like copying memory across array to match dimensions, but there is no actually there is no copying memory. This is just an abstraction to think about it. So there is no memory overhead, and NumPy just acts like if this is happening under the hood. So what this allows you to do is to do things like rather than writing your loops around two arrays, and in Python you can express this with broadcasting syntax, and you get much faster version and much faster computations and also much cleaner code. So you don't have to worry about loops, and well, I showed it here for the addition, but it works for any binary functions. And one more nice feature about NumPy you might not have seen before. We have a 3x2 matrix here, and what will happen if we add these two together according to broadcasting rules? Well, we got a value error because our shapes are 3x2 and 3 length array. So there is no way to merge those together. We can left pad array with ones, but then we just can't expand this to match the matrix shape. So here comes NumPy new axis, and what it basically does, it takes the array and adds a new axis here, and you can add a new axis wherever you want, and it's very useful when you want to reorient your array somehow to broadcast it in a way you want it. So does it still make sense? Well, because at my lecture in university, most of my students were lost at this point. Okay, I see. Once again, broadcasting doesn't add additional memory. It doesn't actually allocate new array. So the last idea I want to talk today is NumPy aggregations. And NumPy aggregations is a function which summarizes the values of the array somehow. And as an example, I have a mean function, and NumPy has a bunch of aggregations are built in, like minimum, maximum, sum, etc. And again, it's something that if you are writing it out raw, you have to write a loop, Python loop. So you could loop over this array and do it yourself, but it's much faster to do this using built-in aggregations. And one more nice thing about NumPy aggregations that aggregations can do is to work on multidimensional arrays. So if you want to get the mean value of the entire array, you do x.mean, and if you want the mean value of the columns of the array, you pass the axis argument there. So you got the mean of your columns. So there is a lot of aggregations available in NumPy, and you should get familiar with them if you're going to do some large scale data analysis. And the cool thing about them is all of them have the same call signature, so you can pass axis parameter to all of them. Well, so in a quick summary, writing Python is fast, but loops in particular are slow. And if you are looping over the large data set, that the best way to do this is to use NumPy package and to try some of these techniques. And the very last little thing I want to show you is the example of how it can be used to implement a meaningful algorithm. So we will use a k-means here, and I believe all of you know this algorithm, and this is clustering one. So it's a quick reminder how algorithm sounds. Well, you select k points and random and cluster centers, and assign object to their closest cluster center according to Euclidean distance, and then calculate the centroid or the mean of all the objects in each cluster. And then you repeat steps 2, 3, and 4. And here we just generate some synthetic data to work with it. And here it is. It's a visualization for this data, and we have a bunch of points floating in the space. And we want to compute clusters for each point here. And basically, what we're going to do, we're going to compute Euclidean distance, and here we got a vectorized version of it. Oh, sorry, here it is. Just 5 lines of code. And here it is. It's algorithm implemented line by line like it was written before. And so I took these words definition, and I just managed to translate it line by line into Python. So it can be achieved by pure Python without NumPy arrays. But, well, this makes me really excited. And here it is. So I believe we just out of time, and I'm going to leave you with this. And if you are interested in these slides, you can go to my Twitter account, and I'll post a link to slides there. And I want to thank you for listening, and I hope this was helpful. And please enjoy the lunch and the rest of conference.
Well, thank you, Ekaterina. Now it's time for questions if you have some. No questions, really?
It's great.
Okay.
Have you ever compared NumPy performance with PyPy? For example, if any of your students refuses to use NumPy, but you still need to check the assignment, you can just run it on PyPy to speed up.
Well, PyPy and Numba and etc. Well, for instance, just-in-time compilers are great ideas, but it doesn't fit this talk. Sometimes it's faster, sometimes NumPy beats PyPy, so there is a lot of work should be done.
Thank you.
More questions?
Okay.
Hello. Is it easy to write a custom universal function?
It's perfectly easy. Well, I like NumPy because you can write a universal function yourself, and then just it will work like a built-in one.
Okay, thank you, Ekaterina, for coming.